So this is a talk about hacking blockchains. If you're here for something else, you're in the wrong room. Let's just dive in. There's a lot that I need to cover. There's a lot that I want to get across, so I may talk a little fast, but we'll get through this, and I have all the resources will be listed after. I'm sharing the slides after, so it's all going to be out there. So let's dive in. If this worked. I guess I need to put the USB in first.
Wait your 10 seconds.
I know I wasted 10 seconds. That's what I happened before. All right, so this is me. I'm a senior security researcher at Security Compass. In case you're wondering how that name is pronounced, it's Hnatiw. Gotten the question already many times. You can find me on Twitter. It's probably the best way to reach me. A lot of this research that I don't include it all in my talks, but a lot of this stuff that I find and stumble upon, I usually just post on there. So it's Inspector with a 3 and an RE. Pretty easy to remember. So I've done a lot of things in IT, which helps contribute to a lot of the research that I do because I'm able to kind of see things from a lot of different perspectives. And yeah, Security Compass, who I work for. So let's dive in. This talk, what is it actually about? Well, this talk is here to give you the fundamentals you need to be able to start taking on hacking blockchains and hacking cryptocurrencies and what is involved in the security of blockchain technology. And it is a very big buzzword right now. I understand that, but you'll understand why the word is what it is and what it actually means soon enough. So I want to give you the understanding about what is involved in it, how the technology works, and then I'm going to spend a significant chunk of time on the security implications of blockchain as well. So let's dive in. Here's the topics. Like I said, I'm going to cover what blockchain is, talk about cryptocurrencies, other uses for blockchain right now, and then I'm going to race through to get to the security portion so that we can cover that a significant amount. So let's start with what is a blockchain? Well, it's pretty basic. It's literally a chain of blocks. Each block itself holds a list of transactions in it, all the way back to the very first transactions. And those transactions are basically a transfer of tokens. Those tokens have value depending on what cryptocurrency or what blockchain you're on, but the idea is that it's literally blocks that build on each other that form a chain. So it's an easy way to remember that. And it's also a distributed ledger. So this is how the layman will view it, but for us that are involved in technology, you can think of it as a highly distributed, very high integrity database that is almost impossible to reverse unless you have a lot of computing power, which we will get to later on. So let's dive into cryptocurrencies. These are those tokens of value that I was talking about. And there's a ton of different ones out there. And really the main one is Bitcoin. Bitcoin's the primary one. This is the one that started the whole blockchain thing. I'm not going to say that it's the first of its kind because it built upon the shoulders of a lot of other research, including things like Hashcash and B-Money. But it is a distributed pseudonymous currency that no one system or owner controls. It was first introduced by Satoshi Nakamoto, and I say that with air quotes because we don't know who that is or if it's a group or anything. But it was introduced in a white paper in November 2008, and then originally the first block was mined in 2009 in January. What's cool about it is that the entire thing is open source, all on GitHub, MIT license in C++. So you can take it, you can do whatever you want with it, completely free and easily. So that's Bitcoin. Here's a link to, again, I'm going to post all these later, so don't worry about scrambling to write all this down. This has some of the research that was done before Bitcoin was released that heavily influenced Bitcoin as well. So you can get a background, and if you really are curious about what the technology built upon, check that out, and there's a lot of really good white papers there. So the original requirements of Bitcoin were that 1, it was private, 2, that it's anonymous, 3, that it is censorship resistant, so you can't really easily shut it down. There's no central point that you can stop. And the Byzantine attack resilience. So there's another point, but I'm going to kind of delve into this for a second. Byzantine attack resilience refers to a computer science program known as the Byzantine generals problem. And what that is it's a problem about achieving consensus in an untrusted network. So everyone agreeing when we don't trust each other. So the story goes like this. Picture the Byzantine army surrounding a city, and you have, let's say, 5 generals. They all need to decide whether to attack or retreat. But they need to do the same thing. They all need to agree on one thing. But they don't trust each other, and they would rather take out their enemies than actually do what the army wants to do as long as they survive. So how do you achieve consensus? How do you agree on whether to attack or retreat? And that's the problem. And there's been many ways that people have tried to solve this. The way that Bitcoin solves this is through something known as proof of work, which I will talk about later as well. So that's the Byzantine generals problem, and that's what this is trying to solve as well. And then it needs to be decentralized. It's not truly distributed now because of the whole hot wallets and trust in not running full nodes, but it really is decentralized. So let's talk about briefly how it actually works from a technical level when you're quote unquote mining a block and what is involved in that. Because this is really a fundamental concept to how the blockchain is built. So first off, what you do is you broadcast all the transactions that you've done and everything that you've seen on the Bitcoin network. So we're going to talk about Bitcoin here because everything's really built upon that later on. There's some variations, but this is really what started it all. So you broadcast all the transactions you have around the network, and those get stored in what's known as a transaction pool on the nodes. So every transaction that you make, let's say I send a Bitcoin over to Alice, that gets sent around to everyone around me because it's decentralized. We're all connected in some way. And then each node, if you're running a full node, which means you're actually doing the quote-unquote mining, you're collecting this information, these transactions, into what's known as the transaction pool on this node. So you're collecting them all together, and then what you do is you put them into a single block. So a block has a limit, a size limit. It's changed over time. This has been caused dispute. I'm not going to talk about the specific limits of it, but understand that there is a limit to the size of number of transactions you can include in a single block. So you collect them into a block, and then from there you work on proof of work. So proof of work is a key concept here, and it's something that is usually pretty difficult to explain. But the way that what it is essentially is a way of achieving consensus, like I said, solving that Byzantine generals problem. So what it is you are basically solving a really hard problem, a really hard computational problem with your computer, and the person that solves that problem first gets to propose a new block on the network, and everyone just says, okay, because it took them so long, because it was so hard for them to do, we're just all going to agree on that as long as the transactions and everything inside of that block are valid, which I'll talk about in a moment. So that's what proof of work really is from a high level. From a technical level, what that computation is you're trying to calculate a hash. So you take a hash, and specifically in Bitcoin, it's SHA-256, but you're taking a look at the previous block ID. All the transactions are hashed inside of that block, as well as a nonce. And you're trying to achieve a number that is less than a target number that is agreed upon by the network. The target number changes every 2 weeks. So every 2016 blocks, roughly every 2 weeks, it changes so that the difficulty is high enough based on how long it's taken people to calculate these blocks, so that a new block comes out roughly every 10 minutes. So this is changing constantly. The last target number, the last time I checked, was this. So it's a pretty high number. It doesn't look super high, but the odds of actually being right are this. It's a very difficult problem. At the very beginning, it was not even close to this. But as you can tell, it requires a lot of computing power. In fact, it uses so much computing power and a lot of electricity in doing so that it's estimated that by 2020, the global power output from Bitcoin itself, from mining Bitcoins, is going to be greater than the country of Denmark by 2020. And it's probably accelerated given the price of Bitcoin now. So it's a lot of power, but the trade-off is you're trading this power, you're trading this computation, this difficult problem to have someone be able to propose the new blocks and the transactions that are accepted on the network. So that's what proof of work is all about. Next, once someone finds that block, they then broadcast it to the network. Because remember, it's decentralized, so we spread it around to other nodes in the network. So it's passed around, and then those nodes can then validate whether it's acceptable or not. And acceptable means that it is a valid block, like the hash is correct, and the transactions in it are valid, meaning they haven't been spent before. And you can trace them all the way back. So all the transactions you can actually trace back to the original point at which it was drawn from what's known as the Coinbase. So basically those coins were created. And I'm going to talk about that next. So you check whether it's acceptable. If it's acceptable, then people will then move on to the next block, but I'm getting ahead of myself. If it's acceptable, then you get a reward. So the reward is basically the miner that proposed the correct block. They've solved that problem. They then get Bitcoin out of what's known as the Coinbase. So it's a number, it's a value that is they include in the block. So you know those transactions that they included in the block? One of those transactions was saying from the Coinbase is Bitcoin is being sent to my wallet. And so this is the projected rewards. You probably can't see this again. It's being posted after, but understand that it started at 50 Bitcoins in 2009 when it was first produced. And then every 4 years it gets halved. And eventually there's going to be no reward. So the economic incentive is with every single transaction you do, you actually propose a tip or a transaction fee. And miners will look at the transactions that have the highest fee and they will take those because they then get that as a tip for including your transaction in the blockchain. So that's the economic model down the line. The implications of that are eventually tips are going to get higher, and that's going to be incentive enough for miners to continue mining blocks. But this is the rough output. Just understand that miners get rewarded for doing this hard problem, solving this hard problem, and proposing new blocks on the blockchain. And then once that reward is given and the block is spread out throughout the network, all the miners on the network, all the full nodes start working on the next block on the chain. So you have this long chain of blocks that build upon the last ones. They start building on the next one. Now, the problem comes in with, what if two people solve the block at the same time? Because you can have a large, there's no one single nonce that will solve the problem. There's a number of different answers that you can have. So you can have multiple people solving the next block validly at the same time. In that case, what happens is the blockchain essentially splits. And so you have A and B, different blockchains, and because it's sent out to nodes around them, the nodes, as soon as they see the next block that comes along with the longest chain, they start working on that. And you essentially have it split so that some people are working on this blockchain, some people are working on this blockchain, and eventually one person is going to solve a block on one of these two chains. It's very unlikely that two people solve it on that chain again, but because of the difficulty involved in it, it significantly reduces the likelihood that any two blocks will be mined. You won't have a split for very long. Once another person finds a block on one of these chains, as soon as it gets broadcasted around, the rule is miners will work on the longest chain. So the reason they work on the longest chain they see is because it took the most amount of work. And that is what we use to agree on what is the valid blockchain. Okay, so that's a common problem that you may think about when you're talking about blockchains, and proof of work is really the way that we solve that. Okay, so that's how blockchains are calculated. That got really nitty gritty. It's very there's a lot more to it if you want to look into it, and it's different, slightly different for different blockchains, but that's the general idea. Side note: Bitcoin's gotten pretty expensive. I don't really need to tell you this because everyone knows it now. And so let's talk about altcoins. Altcoins are interesting. Essentially, this is just different cryptocurrencies that have come out. A lot of them are based on the original Bitcoin, but they all have a different thing that they propose, a differentiator in them that you'll see. So I'm going to briefly cover these because it means that you don't have to, if you're looking at the security of blockchains and you want to just start researching this, you don't have to look at Bitcoin. Bitcoin is the main one. Ethereum is the second main one, which I'll talk about later. But there's a ton of them out there. And so I'm going to cover briefly a few of them if you want to take a look at them. And one thing to note is because, again, all of these kind of came from Bitcoin, if you find an issue in one, you'll likely find a similar issue in many other ones too. So there was color coins. These don't really exist much anymore, but they were basically, they existed upon the Bitcoin network. And instead of using Bitcoins as currency, there's a small value where you can put in data in each of the Bitcoins, and the data would just hold an arbitrary value. And if your client understood what that value meant, then it would essentially stand for something else. So it could be, instead of a Bitcoin, the Bitcoin is a token for a share in a company or something like that. These don't really exist anymore because of the value of Bitcoin. It has skyrocketed, so everyone just wants to use that as a currency now. Then there's Dogecoin. It was just started as a joke, but it had much faster block time, so people were able to mine it super quick, and people were just throwing them out left, right, and center as tips. It was just a fun thing. Litecoin introduced a memory requirement, a higher memory requirement, so you don't have application-specific integrated circuits. So people have literal integrated circuits that are built just for doing a specific type of hashing. This is how people do Bitcoin mining now with SHA-256. There's now Litecoin miner machines that kind of do this too. So that was the original first one to kind of propose something to combat that. Peercoin, proof of stake. So I mentioned that proof of work is how Bitcoin solves it. Proof of stake is another proposed way of solving the consensus problem. Proof of stake essentially, I'm not going to dive into it too deeply, but understand that it basically means in most implementations that the more stake you have in the currency, so the more currency you have, the faster or the better chance you have of computing the next block. So the way I kind of look at it, maybe a little cynically, is that the rich get richer a lot easier. So Peercoin was the first one to propose proof of stake. Primecoin, instead of wasting electricity just to achieve consensus, you're using the electricity to actually calculate primes for science. So all that computation power is being used to calculate scientific primes, which is a problem that many academics actually need to solve. So it is going somewhere else. So it's kind of an interesting twist on the proof of work problem. Darkcoin and Dash basically strings together a bunch of hashing algorithms. Monero introduces private transactions. And Zcash is really cool. I'm not going to talk about zero knowledge proofs because, to be honest, it goes way over my head. But it's completely anonymous. And because of that, it was actually very, very popular around ransomware as well. So let's talk about Ethereum. Ethereum is now the second most popular cryptocurrency on the market right now. And the reason for that is because it's not just a cryptocurrency. It really evolved what blockchain technology can do. So it's very similar to Bitcoin in the sense that it's a cryptocurrency, but it has some small differences and it has some major differences. Some of the smaller differences, again, this actually came out, it was proposed in 2013 by Vitalik Buterin, and it actually came out and first went live in July 2015. So it is just over 2 years old. It's very, very, very new. It has a different hashing algorithm. It doesn't use SHA-256, it uses Ethash. It has a shorter block time, so about 14 to 15 seconds to calculate a new block. And then it actually has block rewards that don't cut in half, they just remain the same over time. So every time you mine a new block, you're always going to get the same reward. They're also looking at implementing proof of stake as well with a proposal called Casper, but it's not implemented yet. It's currently using proof of work. And this is the value of it. It is very volatile. But the last time I checked, it was about 307. And it's skyrocketed. Think about that. That has gone up since July 2015. It's huge. But what really makes a difference, the difference between Ethereum and Bitcoin is what's known as the EVM, or the world computer. It is essentially every single node that runs on the Ethereum network has an EVM interpreter. So you think JVM, it's not an interpreter. Think JVM in Java. It allows you to read JVM bytecode. All of the computers that are running full nodes can read EVM bytecode. So it is a distributed network of systems that not only, in mining Ethereum, they're actually able to run distributed applications on these systems worldwide, which is really cool. So you have a bunch of systems worldwide where you can program an application and then call it, and you don't know where it's necessarily coming from, but you can run it across a large number of systems on the Ethereum network. So it's building distributed applications on the blockchain, which is really, really cool. It was a very, very different. It was very different than Bitcoin in that sense. So what I was talking about is distributed applications, are otherwise known as smart contracts. So it's essentially an application that has a set of rules that when you call it, it will run those rules or will run those functions. Just think of it as a distributed application. What's cool about smart contracts, so to prevent smart contracts from doing like a DDoS, so if you just keep calling it on all these distributed nodes and sending it traffic somewhere, every action like add, multiply, store, all these small actions cost gas, which is translated to Ether. Ether is a currency on Ethereum. So it actually costs you money to call and run these applications. So two things from that. One, you have to optimize your programs to make sure that they are as efficient as possible if you want them to be cheaper. And two, it prevents you from running a DDoS network, essentially. Unless you have some kind of flaw that allows you to produce unlimited Ether, you're really not able to do something like that, which is actually pretty smart. So smart contracts, they led to the next evolution of Ethereum and the next thing that people started doing on Ethereum, which is known as DAOs. These are distributed autonomous organizations. So it's entire organizations built on the rules of a smart contract. So it is run based on rules in a smart contract and people owning tokens that allow them to interact with that smart contract. So the most famous instance of that to date was known as the DAO, which I'm going to talk about later in the security section. But the DAO was essentially a hedge fund built upon Ethereum. So people bought into this hedge fund. It raised about $150 million in 21 days. They bought into this hedge fund. They had a token that could interact with it, and they basically voted with that token on what companies or what things that hedge fund was going to invest in. So it was really, really successful. Shortly, for a little bit. And so that was one of the most famous instances of a distributed autonomous organization. But the next step after that was ICOs, initial coin offerings. So this is probably, many of you have probably heard of these or seen these in the news lately. What they are is, you think of an IPO. When a company goes public, you can buy stocks on the company. Well, the same thing is when a DAO goes public or when a DAO goes live, you can invest in it. So with the DAO, for example, people would invest money and then they get the token to be able to interact with it. So you're buying tokens to interact with that organization, essentially. So ICOs are the same thing, but on Ethereum, essentially. They're very sketchy right now. I would highly advise against investing in ICOs right now, just because it's it's full of a lot of cons. Initially, so back when Bitcoin originally came out, many people were doing pump and dump schemes, essentially. They were forking Bitcoin, didn't do anything different, and they basically just pulled a bunch of people, said, hey, we all believe that this is worth something, so they got people to invest in it. And then as soon as the price of that currency, let's say it's like Acme currency, went up, then the person that created it, because they had a whole bunch from doing the initial mining, they essentially pulled out, sold all the tokens, and then they had a bunch of money because everyone believed it was worth something. So those were pump and dump schemes at the beginning. ICOs are kind of like the newest form of fraud in blockchain. So just be careful when you're looking at them. But it does allow an organization, someone that's actually trying to start an application or start a company on the Ethereum blockchain, it allows them to raise money so that they can do what they need to do, their operational costs, similar to any kind of, a Kickstarter or, a Series A, Series B, seed funding, anything like that with a regular company. So that's what it's there for. So next I'm going to talk about some other uses for blockchain. That was Ethereum. It's really exciting. There's a lot of stuff going on there, and it's actually really cool because it takes a whole new aspect to blockchain than we've ever had before. So let's talk about other uses of blockchain technology. There's some really exciting things going on here, and there's so much more that's coming every single day, but I'm going to cover a few of them that I've seen lately. One is voting. So because it is a high integrity database that is irreversible, if you give everyone a token and they can vote and you know who's associated with what tokens, theoretically it's actually a very efficient voting system. And so some places are actually implementing this as well. Tracking digital assets, because it's like I said, a highly distributed, high integrity database. If you just take a hash of that digital asset and you associate it with a specific person's wallet, then you know that that person owns that digital asset. So it's being used for things like music, digital photography, things like that right now. Tracking physical goods as well. So if you look at a lot of shipping companies are starting to use blockchain to track their shipments across the world, and it's very effective at doing that. Because again, you can't go back and just change the numbers very easily. It's a really good choice for that. Commodities. There's a few companies that are doing. They're essentially associating a token or a Bitcoin or a whatever currency they're building it on. There's two that are doing it on Ethereum. One is Digix. It's basically associates one token with 1 gram of gold. It's stored in a vault in Singapore. So, I mean, it's up to you whether you want to trust that or not, but it's there. There's also one called Tether, which ties one token to $1 stored in a bank account in Hong Kong. And then some allow you to do marginal trading. Or margin trading rather. So there's some interesting thing that you can do where you can just basically tie your token or your coin or whatever to a specific commodity as well, which is historically very difficult to do, and not many people do it on the stock market because of that. Pegged sidechains. The idea of pegged sidechains is efficiency. Efficiency for microtransactions. So if you think about the blockchain network where you have a certain size limit on the blocks and you also have a certain limit to the amount of time between transactions being broadcasted on the network, it's somewhat slow and it's limited in resources. So you can't, if you have, okay, I'll give you an example. Let's say you're at a gas pump and you're pumping gas, and for every ounce that you pump, it costs a certain amount. Let's say this is going to be expensive gas, but 1 Bitcoin per ounce. So every ounce you do, it costs a Bitcoin. It tracks it. And you can't just keep throwing those on the Bitcoin blockchain because it will quickly fill up the blockchain because of how often that's being done. So what people are doing is you actually implement a side chain or a separate blockchain that's being used that you can even just store on the gas pump itself. It stores all of the microtransactions, all the gas that you pump. It stores all those transactions in that chain. Once you're done, it aggregates it together as one transaction, saying it costs a total of, 120 Bitcoins for this, to pump this amount of gas. And then it sends that up to the public Bitcoin blockchain so that it is stored for everyone to see. And it is there for eternity. So instead of trying to store everything on the one public blockchain, it uses a side one, aggregates them, sends it up to the main blockchain. Like I said, it's about efficiency of microtransactions. And decentralized file storage. This is actually kind of cool. You can get paid to host your hard drive space, and you can also pay to store your files distributed across the world. And it's cheaper, I think, in a lot of cases than like something like S3. So it's really cheap right now. There's a few that are doing it. Storage and IPFS, which has now become Filecoin, are a few companies that have done that. But it's just another idea of things that you can do with blockchain technology. And there's so much more. Like, I'm sure today they've come out with 50 different companies that do different things on blockchain. So it's evolving very, very rapidly, which means there's a lot of space and a lot of things that you can do, a lot of coverage we can have as security professionals to actually, like, there's a lot of things we can look at, basically. I had a friend that looked at one of those distributed file storage companies and took a look at their source code, and there was like no error checking at all. So if there's no error checking, it's likely that there's probably other issues. So there's lots of things you can dive into as a security professional. Again, I want to point these out so you have a jumping off point. All right, so I raced through that so that we could get to security, because this is the interesting part. So there's some known flaws in blockchain technology that that every time you're implementing it, you have to consider these things because they are known issues. And some of these things are also issues specific to specific cryptocurrencies. So let's get started into the first one, which is the majority ledger problem. So majority ledger problem basically means that if you have, in proof of work specifically, if you have 51% of the global computing power, so if you have more computing power than everyone else combined, you can do things like go back and change the blockchain. So you can change transactions that were put in and build the blockchain fast enough to the point where you eventually have the longest chain, and then everyone will jump over to that. And all those other transactions that happened before are gone or they're negated. You can basically undermine the entire cryptocurrency. And because of that, the economic incentive is not there for you to really do it. Because it's actually, if you have all that computing power, and you do something like that, you're undermining everything. You're undermining what you're actually trying to steal. And so no one's going to believe in Bitcoin anymore. And then you're going to, like, what's the point of doing that? The value that you're trying to steal is going to be worthless. So that's the economic incentive behind, it was actually addressed in Satoshi Nakamoto's original paper. He talked about that specifically, but it is possible. And depending on your use, if you're implementing a new blockchain or how you're using it in your organization, understand that the 51% problem exists if you're using something like proof of work. That's how that works. Double spend. This one basically allows you to create money or easily defraud people of a cryptocurrency. So this is very easy in Bitcoin because of the long amount of time that it takes to calculate blocks. But the way that it essentially works is I can go to, let's say I'm going to a coffee shop and I want to buy a donut and it costs 1 Bitcoin. If I go, it's an expensive donut. I'm going to go to the coffee shop, buy the donut, give them my 1 Bitcoin. It goes into the transaction pool, and then I leave. Because they don't want their customers to wait around for 60 minutes to actually confirm that it is for sure on the blockchain and it is definitely in there and it's not going anywhere else, I can then turn around once I walk out and make a same transaction with that same Bitcoin to my own wallet and just say, hey, I'm just going to send it over here instead. It's in the transaction pool. The key difference, the key thing to do if you're going to be trying something like this is if I change the tip amount or the transaction fee, let's say I did a tip of 1 Satoshi, which is an 1/8 of a Bitcoin, to that original transaction for the donut, but I send myself a Bitcoin and I do 0.001 Bitcoins, well, that one is definitely going to get picked up by the miners around it because they have more incentive to do that than the other one to the donut or to the coffee shop. So it's going to get put up in the blockchain. I'm going to get that in my other wallet, which is still mine. And that coffee shop owner is going to get nothing because every single miner that sees that transaction, that first one, they're going to see it and they're going to say it's invalid because that Bitcoin has already been spent. So that is the double spend problem. It's essentially, it's a problem that is really big in Bitcoin when you deal with microtransactions like that. And so this is one of the blockers of it getting into the mainstream for things like, buying, a coffee here and there. One recommendation to get around this in blockchain or in Bitcoin rather is because it's 10-minute, every 10 minutes a new transaction comes out. Just because your transaction gets included and you see it on the blockchain after those 10 minutes doesn't mean that it's for sure going to stay in there. Because remember, it could split. Someone could have not included your transaction and then that chain gets built up higher and yours doesn't get included. And during that time, whoever you sent it to or the person that sent you that Bitcoin, they could go and spend it and send it to another wallet in the meantime. So the recommendation is to wait about 6 blocks. So that's about 60 minutes after you make a transaction and it's included in the blockchain to be sure that it is going to stay there. Which is not always feasible for a lot of things, but it is just something good to know, especially if you're making transactions that you can wait a little bit longer for. That's the double spend. Basically creating money out of thin air, easily defrauding people, and you get to keep Bitcoin from it. All right, this is a more theoretical issue. This is essentially a collision. So if you can find a way to generate a valid private key for a public, because every wallet is a public-private key pair. And so if you know a wallet's public key, which everyone does, and let's say they have 200 Bitcoins in there, or it's an exchange and they're only using one wallet for some reason, then if you can calculate a private address for that, then it shows that you have ownership over that wallet, and you can drain it, send it wherever you want because you have ownership. It's highly theoretical because in doing so, you're essentially creating a collision in the, it's RIPEMD 160 is the hashing algorithm that it uses to calculate private public key addresses, so generating wallets. So it's difficult to do that. In fact, it is this difficult. That's the chance you have. That's 49 decimal places of calculating a collision. There was a project that tried to do this called the Large Bitcoin Collider, where everyone started using that. I see some of you are familiar with this. Everyone started using this software to try to calculate these collisions. Plot twist was that it actually had a backdoor. So people that were using it really got owned. So it wasn't pleasant for them. But someone tried to do it. However, again, a lot of these blockchain and especially cryptocurrency issues are negated by the economic incentives for it, because it would currently take 2 to the 107 times longer to generate a collision or a colliding Bitcoin address than to just mine a block. So why not just mine a ton of blocks, and you probably just generated more than you would have had from stealing someone's Bitcoin wallet. But it exists. So this is a problem especially if you're looking at implementing a new blockchain, or if you're looking at one of hundreds, if not thousands of other blockchain or proof of work or cryptocurrencies out there, then you have to consider this and take a look at the hashing algorithm you're using or the algorithm they're actually using to generate these public-private key pairs. Yes?
Will there be a point where that is nearly one-to-one, or will the cryptocurrency be mined out by that?
So if I'm going to jam another buzzword into this presentation, if we get to quantum cryptography, in that case, this is the whole problem of it, is that you can then have a ton more computing power to be able to generate this kind of stuff. Assuming traditional ones? I don't know. I wish I could tell you that this will happen in 5 years, that this will become obsolete, this hashing algorithm, but I don't know. Right now, it's clearly very difficult. But Moore's law, right? Computing power is going up over time. Moore's law has slowed down, but it's still going up over time. And there's a lot of big players that have a lot of big computing power. So it is potentially there. Again, if you are using a weaker algorithm to generate these key pairs, then this is much more of an issue for you. And if you're looking at implementations of this that are using a weak algorithm, this might be something to look at. Okay, wallet correlation is the next issue. I'll let you read this. It has nothing to do with wallet correlation. It has something to do with correlation. That's all. So the way the wallet correlation works is essentially just linking back a particular wallet to an identity. Remember before I said that Bitcoin, one of the purposes of Bitcoin was to be anonymous? It's not completely anonymous. Remember, it is a ledger of high integrity, and we can track everything back to the beginning from the source. So we know all the transactions that have happened from specific wallets. We know all the transactions that that Bitcoins have been sent to. But you can still hide, if someone doesn't know who's associated with what wallet, it's kind of meaningless. But there's a few things to consider when you're thinking about this. One, all Bitcoin transactions, it's a peer-to-peer network, and when you broadcast all your transactions, it's sent unencrypted. So if you have other nodes on the network that are listening and logging, and you have enough of them, technically you can do some kind of statistical correlation around what IP addresses are sending these new transactions, and you can do timing attacks. There's a lot that you can do for correlation around this data because, like I said, it's peer-to-peer unencrypted. There's also another thing where if you are using an exchange to buy or sell Bitcoin, I know in Ontario there's the KYC laws, the Know Your Customer laws. This is probably enforced in a lot of other places as well. This is essentially where regulators are really focusing on when we're talking about Bitcoin. So all these exchanges, they are financial institutions in a sense. They have to comply to these laws. And so in doing so, they basically require you to give a lot of, they need documentation of who you are if you're going to use their exchange. So in doing that, you're basically you're tying your identity, your real life identity to a wallet. So it is something to seriously consider. Right now, the only true way to kind of be anonymous in Bitcoin is to mine your own Bitcoin through Tor or a VPN you trust, and only use that, which is not really very likely because it's really difficult to mine Bitcoin. Unless you have a huge server farm, or you're a part of a mining pool, it's very difficult to actually get anything out of that. So the second best thing you can do is do something like localbitcoins.com, which allows you to trade cash for Bitcoins, do an in-person transaction, and go on your merry way, and then just apply traditional appsec rules to that as well. So there's a link right here. This is, again, I'm sharing this later, but this is a guide to kind of using Bitcoin a little bit more anonymously. It's got some really good recommendations on there if privacy is a big concern of yours when you're using Bitcoin specifically. Again, there's other things like Zcash that is completely anonymous. I think Monero, you can do private transactions. There's other implementations out there that are like this, but Bitcoin's the biggest one, so just pointing this out so you can keep that in mind. And then I do want to give a shout out to Hnatiw Lavoie and David Descartes-Etu. They are, I believe they're both Canadian, but they created bitcluster.com. It's open source. It's written in Python. It's up on GitHub. Basically, it allows you to do some of this correlation and track Bitcoins and I believe wallets as well over time. So it's this big database that allows you to track everything. It's actually really interesting. So if you want to get into and start looking at what wallet correlation can do and like what you can do in that space, that's probably a really good place to start. Okay, so the next thing I'm going to talk about is a problem that we are all familiar with in security being applied to blockchain technologies as well, and that's smart contracts. So smart contracts are distributed applications, and therefore they have the same kind of security issues as any other application. And it has the bonus of smart contracts are able to hold money. They can have their own wallets. I didn't mention that before, but it's another incentive for people to start looking at the source code of some of these distributed applications. This is the source code from the DAO, the hedge fund I brought up earlier, the one that raised $150 million in 21 days. So when they went live, I think there was a professor that was at some college, I can't remember details. Basically, people were looking at the source code because they published it online, and they found an issue. The issue basically allowed you to exploit a time of check, time of use vulnerability with a recursive function to pull as much of the tokens out of there as you want if you keep calling that recursive function. So you keep calling the recursive function, and you can it's a function to pull out your ether out of there, but it doesn't check how much ether you have left until after the function completes. So that happens down here. They basically trust you to just call it once, but if you can keep calling it from within itself recursively, then you can just keep pulling out as much ether as you want. An attacker did this, and they basically drained the equivalent of $50 million of ether in a few days. In fact, I'm not going to get into this side of things, but it caused a lot of controversy in the whole Ethereum community because it caused them to do a hard fork of the entire blockchain after that to fix the problem of this hedge fund because it was so big. So that's an example of someone making a little mistake, but because it was dealing with so much money, people had incentive to look at it, and no one had looked at it before quite well enough. So if you are familiar with, sorry, do you have a question back there? Or you?
Is alt code for all the smart contracts public in the blockchain?
No, it's not. That's a great question. So the question was, isn't all the code for all the smart contracts on Ethereum public because it's on the blockchain? So it is and it isn't. It is because it's up there in bytecode, in EVM bytecode. And the next slide I'm talking about is going to address that. So the smart contracts that are out there, a lot of them are open source. So if you're interested in appsec, if you're coming from that background and you want to start looking at blockchain technology and the security of it, I would highly recommend taking a look at smart contracts in Ethereum because there is a lot of them and it is growing exponentially. And there's probably a lot that you can find in there as well. So the next slide, I'm going to talk about some tools you can use to actually take apart these smart contracts. So as I mentioned before, smart contracts are stored on the blockchain, but they're stored in bytecode. And you have to know the wallet address. You have to know the address of that application on the Ethereum blockchain to be able to call it. And you have to know the functions to call, but there's ways around that. So a lot of the time it's in bytecode. If you can't actually access the source code, you have to find a way to decompile it. So there's a few tools that you can use to do that. And this is a very, very new field. So like a lot of these tools are kind of flaky, and there's a lot of room for improvement. I believe most of them are open source, and there's a lot of room for people to start building their own ways to do this. So if this appeals to you, there's a lot of room to grow. So by all means, dive in. First off is porosity. It decompiles, and again, if you want to write these down, that's fine, but I'm going to be including this later on. I'm going to be sharing these slides. So porosity decompiles EVM bytecode into Solidity syntax contracts. So you know how I mentioned before how it was how you write smart contracts in a high-level language compiles down to bytecode. One of the high-level languages, the most popular one right now, is Solidity, which is kind of like JavaScript in a way. So porosity basically decompiles it down to Solidity-like contracts, so it's easier to read. It also has a disassembler if you want to look at it at the pure assembly level as well. There's EVM dis, which is an EVM disassembler. Surprise, surprise. There's also Securify, which is in beta right now, but I have a feeling that it's going to turn into a commercial service, so just keep that in mind. It's pretty powerful, though. It allows you to basically point to a smart contract address, and it does some automatic security analysis of it. It does it also for source code as well. There's Oyente, which is a pure source code analysis tool for Solidity smart contracts. Remember, Solidity is the most common high-level language right now being used in Ethereum smart contracts. And DoctorWise Ethereum Contract Analyzer. This isn't necessarily a security tool, but it gives you, if you point it to an address on the blockchain from one of these distributed applications, it will then do an analysis and tell you kind of what it does. So it gives you an idea of what the application does from a high level. Which is really useful if you don't have source code. So as an initial step, that's probably where you're going to want to go. Next thing I'm going to talk about is how to actually audit cryptocurrencies and blockchains as well, because a lot of them have these tokens involved in them, which are the equivalent of cryptocurrencies in a lot of ways. So there's a cryptocurrency security standard. It is fairly new. There's a lot of big names in the blockchain community that are actually behind this and helping develop it. But it is a guide to how to audit these things. What you need to look at specifically when you are analyzing these cryptocurrencies for security flaws and weaknesses. And I know a lot of us are allergic to the term audit, but just have an understanding that this basically gives you a process to actually start understanding the technology, to start looking at it from a security perspective. So they give you really in-depth details of what things are good and what things are bad and what you should be looking for in these cryptocurrencies. So it's split over 2 domains covering 10 different aspects. And I'm going to give you an example scorecard here. So the 2 domains are cryptographic asset management and operations. And these are the different areas of it. So many of you can't read this, so I'm going to read it out loud for you. Key and seed generation, wallet creation, key storage, key usage, key compromise protocol, key holder grant and revoke policies and procedures. And then under operations, you have security audits and pen tests, data sanitization policy, proof of reserve, and audit logs as well. So it's still growing. There's a lot of work being done on it. And the last 2 times I checked, there was something new. So it's a rapidly evolving standard right now. And next up, I want to point to some breaches that have happened. And you may sense a theme to some of these breaches. First off, there's CoinDash. CoinDash had a hacked website, and the funding address was swapped before the ICO. CoinWallet had a SQL injection vulnerability, caused them to shut down because of it. And Shapeshift.io had an insider threat. Cryptsy had a backdoor independency code. BitPay, spear phishing to the CFO and CEO. And Allcrypt had a WordPress hack, which they used to pivot to the database access, which got them everything. And then Cryptoween had a web application race condition. So what's the theme with all of these breaches? Can anyone tell me? Web apps. Web apps is one of them, but at a higher level, none of these were about the actual technology. None of these were about blockchain. So all of these came down to the same attacks that we've seen time and again in our industry that have nothing to do with blockchain. But because it deals with money, people have incentive to look at it. So if you are coming from, especially this infrastructure, networking side of things, security background, or if you're a pen tester and you want to get started in hacking these, hacking blockchain, making it more secure, what you can do is you can actually start looking at the systems between the technology itself, the blockchain technology, and the users, between the blockchain technology and the backend. Look at those things because there's likely a lot of things that are being overlooked, same as in any organization. So I've kind of covered different ways you can come into blockchain hacking from different backgrounds. We have application security. If you're looking at smart contracts, there's a lot to be done there. There's the infrastructure network security side, the pen testing side, looking at things between blockchain and the end user and the back end. And then, there's one point that I didn't really dive into, which was the crypto side of things. If you've ever needed a financial incentive to get involved in cryptography, this is it. Okay? So there's 3 different ways you can really dive into hacking blockchains. So with all of that, I'm going to actually leave you with this. This is a link. I've posted all of my notes, including more than everything I've covered in here, because I can only cover so much in so much time, on that blog post, and it's completely open. So it's in a gist, and anyone can comment. I want people to comment to help improve this, because I don't know everything, and I will freely admit that. But if we can build that as like the source where people can start using to dive into this, to dive into blockchain and security of blockchain, then I am happy to share, and I'm happy to help improve that as well. So understand that this is a new technology. There's a lot that hasn't been looked at, and it's a really exciting field because it is constantly evolving really, really fast. And I hope that after this presentation, you've got a better understanding for what blockchain really is, more than a buzzword, and you have the confidence to actually start diving in somewhere to help secure this new technology that's growing at a rapid pace. So thank you very much. Feel free to reach out. This is my contact info. You can actually contact me through my blog if you want as well. And I'm happy to talk about this anytime. Thank you.